Welcome back. Today we'll be talking about parallel lines cut by a transversal. Let's start with our essential question. When two parallel lines are cut by a transversal, which pairs of resulting angles are congruent? So we want to be looking for congruent or equal angles. So recall, previously we talked about two coplanar lines cut by a transversal and their angles, and we discussed their names. Today we want to see what happens when those two lines are parallel. So it's a specific case or situation. Our first theorem will be the corresponding angles theorem. If two parallel lines are cut by a transversal, the resulting corresponding angles are congruent or equal in value. What do corresponding angles look like? Here's a diagram or drawing. A drawgram? What's a drawgram? A diagram illustrating our two angles. Here is our parallel lines. The red triangles on each one indicates that these two are parallel. It's red arrows actually. And then we have a transversal cutting them. Our corresponding angles are 1 and 5. Since the lines are parallel cut by a transversal, corresponding angles are congruent. If this angle was 30, this one would be 30 as well, 30 degrees. Our next theorem is the alternate interior angles theorem. If two parallel lines are cut by a transversal, then the resulting pairs of alternate interior angles are also congruent. Once again, alternate interior angles are on opposite sides of the transversal on the interior of the two parallel lines. And if we have this situation, angle 3 and angle 5 are congruent or equal. So if angle 3 is 16 degrees, angle 5 must also be 16 degrees. Our alternate exterior angles theorem says if two parallel lines are cut by a transversal, then the resulting pairs of alternate interior angles are congruent. Our alternate exterior. Sorry guys. Our alternate exterior angles are congruent. What does that look like? Two parallel lines cut by a transversal. Alternate exterior are opposite sides of the transversal, both on the exterior. If angle 1 is 40 degrees, angle 7 must be 40 degrees. We're noticing a little pattern here, but don't get too comfortable thinking you can predict how it's going to go, because now we have the consecutive interior angles theorem, which says if two parallel lines are cut by a transversal, then the resulting pairs of consecutive interior angles are supplementary or add up to 180 degrees. So what does that look like? We have two parallel lines cut by a transversal. Angles 2 and 5 are consecutive interior angles. They're supplementary. So if angle 2 is 100 degrees, angle 5 must be 80, and the two added together must equal 180 degrees. And then lastly, we have vertical angles. If two lines intersect, the resulting vertical angles are congruent. The vertical angles are across from each other. So if this blue angle is 100 degrees, the one across from it must also be 100 degrees. Whatever our red angle here, if it's 80, across from it must, or vertical from it, must also be 80 degrees. Let's look at some examples. The measures of three of the numbered angles are 120 degrees. Identify the angles and explain your reasoning. Well, we have 120 degrees starting here. We can go across here to a vertical angle 4, and that's 120 degrees. That's vertical angles. We can also look at angle 5 compared to angle 4, and that's alternate interior angles. And we can look at angle 4 compared to angle 8, and that's corresponding angles. That's not the only way we can do that. There's a number of ways. Notice that angle 5 is corresponding to the 120, so that's how we can get that as 120. Angle 8 is vertical to angle 5, so that's another way we can get the 120. We can use multiple rules to come up with the same result. By the way, since this is a line, the value of a line is 180, and so if this is 120, that means we have 60 left over here, and then vertical angles gives me another 60 there. Alternate interior gives me 60 here, vertical angles gives me 60 here. Don't forget to write your summary and then get today's assignment.